Hi, everyone. Good morning from the Bay Area. Welcome to this webinar. Today's topic for the webinar is Get to Production Ready Kubernetes with Ingress Controller, Load Balancing, and Security from VMware NSX Advanced Load Balancer, which was formerly Avi Networks. So quite excited about the webinar. And, we have been doing this on a recurring basis. Every month, we pick one topic, a very relevant, good topic, and we run these in different time zones. So thanks a lot for attending in whatever time zone you are in. Just a few housekeeping guidelines before I turn it to Palak and Bhushan from our product management team to begin their presentation as well as the demo. So format of this one is going to be, we will have around 30 minutes of presentation followed by 30 minutes of demo. And then the first part will be the quick presentation by Palak, and then Bhushan will be showing you a live demo. And we can engage in Q&As. So at any point you have questions, please put your questions in the chat or not on the chat, on the Q questions panel, and we can help answer those questions. Now, the session is going to be recorded, so don't worry, you will get the recording as well as the slides in a follow-up email. If you find the content really useful, feel free to share it with your co-workers. So those who are who are not able to make it this time, they can either listen to that or and they can always register for the next one. So without further ado, let's see how to get to deploy those production ready Kubernetes with Ingress controller and load balancing and security. Over to you, Palak.
Thank you so much, Surbi. So let's get started, everyone. First of all, I would like to thank you for taking the time and join us today to understand a little bit more about what Avi can provide from a Kubernetes deployment perspective. The agenda would be, we'll run through, what are the typical Kubernetes services that we see in deployment, what is the current landscape, and where the legacy vendors, the open source vendors sort of failed to address the key requirements of a Kubernetes environment. We'll introduce NSX Advanced Load Balancer. It's also known as Avi. Will be used interchangeably during the slide deck. We'll talk about the architecture and benefits. We'll talk through a customer case study where we have seen a lot of success of deploying Avi in a Kubernetes environment, and we'll tee it up with a demo. So I love to keep this session highly interactive, so please feel free to ask as many questions as possible, and we'll be happy to answer. All right. A little about Avi. Avi was acquired by VMware about a year and a half back, and the product Avi Load Balancer is now known as VMware NSX Advanced Load Balancer. So during this presentation, we'll talk about Avi and NSX Advanced Load Balancer interchangeably. When you look at a Kubernetes deployment, and when you think through, what are the Ingress services for AK8 deployment, typically these three stand out. One is certainly the most crucial, which is the traffic management and service discovery. This includes local and global load balancing. You need to figure out how to route traffic to and load balance traffic to the different clusters within a K8 environment. You want to be able to understand health monitoring, your TLS profiles, so TLS termination, cert management, and automation. You want, a Kubernetes environment, you want to be able to enable a CI/CD and canary upgrades, so CI/CD pipeline, and allow for canary upgrades. And then you have the services such as DNS and IPAM. But since a load balancer, since the Ingress services sits right in front of your application pods, you also want to think about security. You want to think about how do you secure access to that application from the external world. So within the security category lies the network policies, the rate limiting policies, authentication, whitelist, blacklist, DDoS mitigation and detection, and web application firewall. And to tee it all up, you want observability. So you want to be able to go ahead and see what is happening within your environment from an end-to-end transaction perspective. What type of client is logging into the application? What is the experience of the end client? And to that effect, you want to be able to do transaction logging at the HTTP level, and you want to be able to see what is the latency in the application response time, right from the client's request to the response. And you also want to be able to monitor your application infra and performance matrix. These are the three categories of services that sort of tie up what is required for a production-ready Kubernetes environment. Now, in today's world, if you look at this diagram, to provide traffic management, you would typically require a GSLB. If it's a multi-cluster deployment, you'll require a service-side LB, so a layer 4 load balancer. You'll require Ingress controllers for a layer 7 load balancing. So herein, I talked about at least 3 components that you require for traffic management. For security, you may require WAF. You may also require DNS and IPAM for ancillary services that you need within your K8 environment. So if you count the different black boxes here, there are at least 7 different point products that you may need to deploy to be able to realize all your Ingress services. Now, what is, one may ask, what is the problem of deploying the 7 different point products? Like, how does it matter when you're trying to deploy this, as long as you get the functionality? But it certainly does matter. Multiple discrete solutions will result into complex operations. Why? Because these products will be at different maturity cycles with respect to automation and observability. And it will depend on the end customer to be able to stitch the point products together to have a meaningful production deployment. There will be lack of observability because, as I mentioned, some products may provide only partial observability versus an end-to-end transaction login and end-to-end visibility into your underlying environment. And partial automation. Some products may provide some level of automation versus just APIs. And again, it will be the onus of the end customer to sort of clobber this different set of products together to make a production environment. So this proves to be a current challenge. Now, if you sort of look further, like why is Ingress a real blocker in getting a production-ready Kubernetes deployment? The previous diagram showed a set of disparate tools. It showed, some tool for LB, another tool for GSLB, another tool for analytics, DNS IPAM, WAF, and Ingress. And if you are using a set of, different tools, you may get by in a lab project. You may get by in a POC environment. But certainly this will prove to be a big blocker when you want to productize and have production deployable applications that may generate revenue for your businesses, lines of businesses. And what are, one may ask, what are the typical gaps that you see when you deploy different products to kind of clobber together an environment in a K8 scenario? The gap is, how do you guarantee app availability? How do you make sure that your application is resilient? How do you guarantee performance, end-to-end performance? Because now your performance is restricted by the least common denominator. It depends on the performance of the different point products that you have deployed within your environment. How do you guarantee responsiveness? How do you make sure that you're able to administer the different products in a simplified management? And how do you guarantee application observability across these different point products? The goal of trying to move towards a modern application environment is to be able to provide your business outcomes faster, in a more efficient manner, drive change within your environment, and provide a developer-centric environment so that you can drive change and you can have more business outcomes sooner rather than later. Just using this point products defeats that purpose. What you really require is a consolidated services approach where you have one product that does all the Ingress services required in a Kubernetes environment.
Hey, Palak.
Yes.
So can you please go back to slide 4, the challenges slide? So there's a
Sure.
question that where is the layer 7 load balancer in this picture? Where we have the GSLB active standby layer 4 load balancer. So the question
Correct.
is, where is the layer 7 load balancer?
So the Ingress controller is basically is what represents a layer 7 load balancing. The Ingress function is the one that provides the layer 7 load balancing to the actual applications. Okay, going forward. Sorry, go ahead.
Oh, you please carry on. Just ask this question.
All right, thank you. Right, so going forward, how does Avi's approach differ, right? So with Avi, with Avi's load balancing solution, we have one integrated solution that's comprehensive for load balancing, layer 4 load balancing, Ingress, intrinsic security, WAF, GSLB, DNS, and IPAM. So there is one service engine, there's one data plane entity that does all the functions that I mentioned. It's a single hop solution. It's a single pipeline solution, which means that you are not moving the packet across different components and trying to figure out what is happening across those different components. It's one solution that provides all the features and functionalities required for you to run your Kubernetes environment more efficiently. It's operationally simple. We have a single central management and a single pane of glass to see all the visibility and analytics. So you can see what's happening within your environment when things are going wrong or when you are experiencing latency. You can exactly see which component is not performing well. It has rich observability, and there are not enough words on the slide that can do justice to the observability. So we have a demo section dedicated just to talk about observability. We'll show you in real time how our analytics engine can help you debug and operationalize your environments. And the last important point is that we have cloud native automation. So with a Kubernetes environment, you will see that with the Avi solution, you will never need to get onto an Avi controller. You will always be able to manage your layer 4, layer 7 policies through your kubectl commands or kube APIs, and they get automatically translated into an Avi speak. So we have cloud native automation, which allows us to do elastic scaling based on things that we see within your environment and take actions based on the policies which are written in a Kubernetes language. So let's see how Avi fares well with respect to different open source components. Open source components are typically operationally lightweight. They do a point function. Some will only perform layer 4 load balancing. Some will only perform layer 7 load balancing. They may not be highly redundant or may not provide HA capabilities. They may not have end-to-end analytics, and in itself they are generally operationally light, because the whole goal of an open source project is to be able to provide enough so that you can do a POC or a lab project, right? So they can be very operationally light, but to actually productize it, it's a significant DIY based automation. So the onus is on the customer to be able to create the tools around an open source project to be able to provide your enterprise grade experience with it, right? So the onus is on the end customer to be able to provide analytics, visibility, debuggability, redundancy, and whatnot. It is also lacking in features, right? So it doesn't have the enterprise grade features, may not have the automation, may not have all the dashboards required to understand what is happening within the environment. And in many cases, it's really non-performant. It's essentially a tool that allows you to pass a POC, but it's not something that will scale as your application requirements scale. On the flip side, you have the legacy vendors, and the legacy vendors may be big hardware devices. They're not essentially built for container environments. They are not flexible and agile to suit the needs of the containers. We see a lot of our legacy vendors talking about API-based automation, but in today's world, in this world of modern applications, API is a given. Every vendor, every product will have an API, and API is not automation. We'll talk about what automation means from an Avi perspective in the next couple of slides, but API is a way to configure a product, but it essentially isn't the intelligence that the new modern container-based environments require. They may be feature rich. Yes, the products have been around for 20 plus years, and you will find them to be highly feature rich, and they're fixed performance based options. What I mean by that is you size your environment once, and based on the size of the environment, you purchase a big hardware or a virtual edition, and that's that. you're not able to scale out based on the needs of the application. You do not get the cloud-like environment where you can elastically scale. If your application requires more throughput, or if your application requires to terminate more SSL connections, you're not able to elastically scale the legacy environments. So that's why it's a fixed performance-based option. Many a times in these cases, the customers will oversize their environment and over provision, right? So if you require only certain capacity, you will get 3x or 4x times the capacity, just thinking about what you may need in the future, and you have to spend that dollars today. The legacy options don't have the capability of scaling in and out based on the operating needs of an application at any given point in time. Now, flipping with Avi, it's operationally simple. We'll show exactly why it is so operationally simple through our central management. We have one central management for all the Ingress services. You will have cloud native automation, so you have we have the ability to understand Kubernetes APIs and kubectl commands and translate it into an Avi speak. We have all the enterprise grade features. We have many customers in production today using our deployment in a Kubernetes setting. So it has all the bells and whistles, plus it's operationally simple and it's highly performant and elastic. This is a key point because with Avi, you do not need to oversize your environment. What you do is you right size your environment at any given point in time. And if that environment needs changes, if the application needs changes, you can scale out. You can create another version of your data plane entity that does active load balancing, right? So there's no need to have an active standby deployment. You can do active deployments, and you can scale out based on the needs of the application. Now, if you go into an AWS or any other public clouds, this is the experience that you get. You have one central management, you have cloud native automation, you have your features, and you also sort of you get your elastic, highly performant scale. Where Avi really differentiates from all the vendors, including any of the public cloud, is the enterprise grade, right? We get all the bells and whistles, all the features required, fine-tuned to the needs of an enterprise class customer with the cloud native automation.
Hey, Palak, can you just touch base on, there's a question, how do I choose between layer 4 and layer 7 with NSX? So can you please just a little bit touch base on the integration part?
Sure. So if you have an NSX ecosystem, after VMware has acquired Avi, Avi is the VMware's load balancing strategy. So if you have an NSX ecosystem, I don't necessarily have a slide here, but we have integrations with NSX so that you can actually log, through the Avi controller. There is the concept of a cloud connector. Through that cloud connector, we can actually log into the NSX ecosystem, NSX manager, and are able to, when you deploy a load balancing element, you're able to configure the T0, T1s, your DFW rules, so that you can now have traffic, both layer 4 and layer 7, reach the end application. So we have that level of integration with NSX ecosystems already to be able to use Avi and NSX together. So is there any other question?
The other question is, Palak, is there an Ingress controller of NSX that is open source that I can test with Kubernetes?
I don't believe there is an Ingress controller with NSX. I do not believe it's open source. So you can certainly test NSX Ingress controllers, but it's limited in functionality in terms of everything that we just mentioned on the slide here, and it is not open source solution. The open source solution from a VMware's perspective would be Contour.
Thank you.
Okay. All right. So let's look at the key attributes of Avi, right? At the heart of Avi's architecture is its control plane. And we have spoken about, we have central management and we have an intelligence system, and let's sort of delve deep into what that really means. Avi controller is the heart of the system. The Avi architecture is based on software-defined principles. What I mean by that is, we have a separation of concerns, we have a control plane and a data plane. And the controller really does all the automation, all the decision making within the environment. So let me sort of go into specific details, to explain what it really means. It is a central management. It figures out, based on the operating environment, based on the cloud that it's running, where to spin up a load balancer, how many right size the load balancer. Not only that, it automatically stitches the underlying network based on its different integrations with different ecosystems. It will go ahead and publish your DNS. It will speak with your DNS and publish your DNS. It will also integrate with your IPAM. In your cloud environment, it will also integrate with your Route 53s if that's what's required. It does all of that automatically. So from a customer's viewpoint, all the customer needs to tell this controller that I need a load balance. I need to load balance this set of applications. And Avi controller will actually go into the underlying ecosystem, discover those applications, present to the end customer so the customer can see visually what applications it wants to load balance. It will create a load balancer. It will select what compute to run that load balancer on. That is something that logic is sitting with the Avi controller. It figures out exactly where to place my load balancer. It will figure out what should be the capacity or what should be the size of the load balancer. It will stitch your underlying network so that you can track traffic. It will publish your DNS records, and it will also integrate with IPAM. And after that, once your application is up and running, it will keep on constantly monitoring your end environment to see if you need to scale out your endpoints. You need to scale out your data plane. So if the application is requiring more capacity, it will actually scale out your data plane. It will also see whether you need to scale in your data plane. So for example, if your one such application has many data plane entities load balancing it and they are partially utilized, then it will scale back in. You can run an active scenario with Avi. It will also figure out whether whether you need to spin up another. If a data plane entity fails for whatever reason, it will decommission it and then it will automatically spin up another data plane entity and replicate all the session state, all the application state, the TLS profile and whatnot on the data plane entity. That is the job of the Avi controller. And this is what we mean by automation. If we look at the end customer's journey, in this case, all the customer has to do is select the applications, tell the Avi controller what cloud Avi controller would be running into, select the application, create the load balancing policy, and that's it. And the Avi controller goes off and does its job. And the job would be figure out placement, figure out if there is enough capacity within your operating environment to see whether the VIP can be placed on an existing data plane entity or do we need to spin up another one. In the case that we do need to spin up another one, it figures out the right compute, the right network to create that data plane entity. It will instruct the underlying cloud. If it's a vCenter environment, it will tell vCenter to go ahead and spin up the service. The data plane entity is known as service engines in the Avi language. So it will tell vCenter to spin up the service engine on the right compute. It will then go ahead and configure the networks appropriately to attract traffic. It will publish your DNS. It will talk to IPAN to get your IP addresses, and your application is up and running. Look, the manual steps that the customer had to do in this case was just one. It was just telling Avi controller what to load balance. And Avi controller, it was a job of the controller to go ahead and figure out the rest. Not only that, it constantly monitors your underlying environment to see what is working within your underlying environment. So if something fails, it will spin up a new data plane entity. If you need to scale out, it's able to horizontally scale out. So that is what we call automation. It's not just an API. APIs are table stakes in today's world, but it is the ability to drive decision automation. It is the ability to see within the environment what is working and take actions accordingly. The data plane entities are the ones that do load balancing, and they are responsible for doing the layer 4 load balancing, layer 7 load balancing, GSLB, WAF, Ingress services, containerized services. All of those functions are provided by the data plane. And the data plane sort of takes the shape and form of the underlying environment. What I mean by that is it can run on bare metal. It can run in the virtualized environment, it can run in containerized environment, and it can run in public cloud, right? We have central management, we have the Avi controller, which runs in highly redundant fashion, since it's the brain of the system, controlling the entire underlying infra and entire underlying load balancing solution. It's elastically, so as you can see, we can scale out the service engines or the data plane entities depending on the needs of the application. It's resilient, so if something fails, we spin up another one and we replicate the entire state, because the state of the application lies in the Avi controller. So when a data plane entity fails, that state is not lost. It is something that gets replicated back again. It's highly automated, and we'll show this to you in our demo, how we have cloud native automation with a Kubernetes environment. And you have rich analytics and observability, through which you can take certain very informed actions based on the underlying state. So you can understand what's happening if your transaction is taking longer to complete. For example, I have a person logging from New Mexico and trying to reach an application, and for that particular request, that response time was higher. What happened in my environment is the answer Avi will be able to provide to you. In fact, many of our customers joke with us and call Avi the mean time to innocence, because it will exactly pinpoint where the problem was, and it will do end-to-end troubleshooting and transaction logging. And then when you apply the same characteristics to security, you're able to learn from your underlying environment and fine-tune your security policies, because you have the entire end-to-end observability and understanding of what attacks are happening within your environment. So quickly, sorry, go ahead.
So, Palak, a couple of questions. So, one is, what kind of IPAM DNS services does Avi controller use? Is this Avi network solution, or can we use other open source IPAMs or DNS services?
So both. I mean, we have inbuilt IPAM and DNS, but you can certainly use, we have integrations. So you can certainly use, your favorite IPAM DNS. We have integrations with Route 53, Infoblox, and others, right? So it's a combination. If customers want to use Avi's natively provided services, we provide that. But if the customers have their favorite vendor that they want to use, then there are many integrations available.
Okay, great. And on your architecture slide, the question is that how many, like one controller manages how many services, upper bound, how many services or data objects?
So in terms of number of webs, right? In terms of number of virtual services, we have tens and thousands of virtual services, depending on the environment that you're running. This is a highly redundant, highly scalable environment. And we can go ahead and post certain resources that actually characterizes the actual number, because it depends on, again, the underlying cloud that you're running on. We have seen our customers reach millions of TPS in 0 to like 10 seconds fairly easily. In fact, one of the biggest e-commerce, one of our e-commerce customers were able to scale out Avi's environment based on the Thanksgiving shopping time frame, and successfully scale out and scale back in their environment. So this is a highly scalable, highly redundant environment. Okay, so let me tee up the product capabilities. If we look at Avi, Avi was created with the goal of creating a platform for layer 4 through layer 7 services, right? So I had a lot of emphasis on the capabilities of the Avi, and it comes from the fact that it was so architected so that the platform is rich, and based on the platform capabilities, you deliver layer 4 through layer 7 services. So the software-defined platform is the one that provides you with central management. It's the one that does elasticity. Is the one that almost is self-healing, because it's the platform, it's the Avi controller that goes ahead and sees the underlying environment and understands what's happening within that underlying environment, and it's the one that does the decision automation. So we have many customers actually creating a self-service environment for the developers based on Avi, because what you can now do is you can give a segment of your resources to the developer based on fine-grained RBAC rules, And now the developer can create a self-service environment where the developer consumes services as they need to cater to the needs of the application. Based on the platform, we have analytics and observability. So we will demo this in detail, so I wouldn't cover a lot of it right now, but you can see app user and security insights. You can see how your users interact with your apps, and that relationship is captured and visually shown to the end users through our analytics portal. You can see, and based on the relationship between the app and the user, you can also figure out, what are the behavioral patterns. Is one region, you can help with A/B testing. You can figure out if is one region predominantly using one sort of a browser versus others. You can also see where the attacks are coming from. If you're seeing attacks within your environment, you can figure out what region, what IP address, etc. And then based on that, you can refine your engine and learn and create certain, ingress security policies. So all of that can be derived from our analytics and observability. And the last is, like I mentioned, we have app services. So the platform was built to provide redundant and highly scalable layer 4 through layer 7 services. So based on the platform capabilities, we provide the services such as local traffic management, global traffic management, app security and WAF, and container ingress services. This is an eye chart. I'm not going to cover all the features and functions, but I just wanted to highlight that any feature that you can think of is supported by Avi. We just do that much better than anyone else in the industry because of our platform capabilities and the automation that we have brought to the market. But anything that you can think of from a viewpoint of features, ingress services, application security, global traffic management, local traffic management, all the bells and whistles are covered by Avi, right? So there is no compromise. Avi is a choice without compromise. You do not need to compromise on automation, or you do not need to compromise on features. You can get best of both worlds with Avi. We did promise you 30 minutes worth of demo, so I'm going to rush through this slide. But really, what we have found our customers tell us is, through Avi, you are able to get agility because of all the automation and simplicity that we provide. And then at the end of the day, since you do not have to clobber together, discrete solutions to provide a production-ready environment, you're able to save costs, right? It's a solution with significant lower TCO based on compared to anything else in the industry, while fulfilling its promise of operational simplicity and cloud automation.
Palak, a quick question. We do have, do we integrate with vRealize Network Insight?
We do integrate. We do have integrations with vRealize Network Insights and Log Insights to an extent today, and plus there is an entire roadmap around how we keep on integrating with the VMware ecosystems. It's a great question. Avi has a better together story with the entire VMware ecosystem while it develops its standalone features and functions. So you'll keep on seeing that Avi as a standalone product will be as rich as anyone else, if not better, in the industry, and we'll keep on innovating in all the areas that I just mentioned: local, global, application security, and container ingresses. But at the same time, we'll have a better together story with the VMware products. Okay. Thank you, Suti. I promise this is one of my last slides. So we looked at the Avi architecture. We looked at, what are the features and functions of Avi. Let us see how Avi actually works in a containerized environment. So this is a high-level design, high-level architecture of how Avi is automated in a Kubernetes environment. For Kubernetes, we have an operator which is known as Avi Kubernetes operator. The goal of the Avi Kubernetes operator, also known as AKO, is to provide ingress controller functionalities and Avi configuration functionalities. So what it does, essentially, it understands your Kubernetes APIs, your commands, your policies that you have written in a kubectl, using kubectl commands or APIs, and then it translates. It basically goes and talks to the Avi controller. It translates it into Avi policies, and then Avi will go ahead and configure your service engines appropriately to be able to route traffic to your containerized workloads. This runs as a pod in the clusters, so it runs specifically in Tanzu. It runs as a pod in the Tanzu cluster. So we have better together integration in Tanzu, where we are able to automate the deployment and the lifecycle management of AKO as well. This runs in a Tanzu environment and a non-Tanzu environment. So we have many customers running this in an OpenShift environment as well. But we have a better together integration with the Tanzu, where the lifecycle management of AKO is automatically done. We have introduced another object which is known as AMKO, which is Avi Multi-Cluster Kubernetes Operator. It basically allows for multi-cluster application deployments. It runs as a pod, again, in the Tanzu cluster, and it extends your application ingress across multiple clusters. So if you have, in a GSLB scenario, if you have multiple clusters, you want to create your global server load balancing policies, which is where the AMKO kicks in and is able to extend your application ingress across multiple clusters for real deployments. Avi controller is the same Avi controller that we spoke about, and Avi service engines are the same ones which we talked about, that does the load balancing and provides the DNS, IPAM, GSLB, and application security functions, right? So they are hosted as virtual services in the K8s or in OpenShift and are responsible for ingresses and routes. It handles all the traffic. So one important thing to note here is none of the data plane traffic. It's the controller. The controller sits out of band and is responsible for programming the Avi service engines. So I would want to tee it up with a case study before we go into demo. I know I'm a little bit over time, but we have Deutsche Bank, who basically created a PaaS platform using Avi. And the key things that they were able to tell us about Avi, and this comes directly from Deutsche Bank, is it's a highly automated load balancing for both North, South, and East, West use cases. It was able to shorten the time to market from 12 months to 3 weeks, right? From inception to production. And this is what we mean by production-ready Kubernetes environment with Avi, is because of our tools and because of the sophistication that we bring it within the environment, you're actually able to shorten the time to production. This was a best-in-class solution for OpenShift. I mean, OpenShift provides a slew of open source solutions or open source options for the end customer, but Deutsche Bank in this case chose to productize their environment and still continue to run on Avi, and it was highly available and resilient and simplifies operations. So, one of the key attributes of Avi is it really doesn't matter which environment we run in. We can run Avi anywhere. And this comes directly from Deutsche Bank. This quote comes directly from Deutsche Bank. So you can get a view of how we are able to transform a customer's environments using Avi. All right, without further ado, I'd like to invite Bhushan to go over a short demo with us.
Thank you, Palak. Can you make me a presenter, please?
Right. Yeah, I just did. Are you able to present now?
Yeah.
Okay, perfect.
All right. So let me get started here. All right. So before we dive into the actual demo, just a couple of slides showing the day zero configuration so that you understand what's happening in the demo. So whenever you have a Kubernetes environment for which you want to have Avi as a load balancing and ingress, the first thing to do is to install the Avi controller. This can be run as a VM in a VMware kind of environment. The next thing to do is to configure the infrastructure cloud. For example, in this case, you configure a vCenter cloud, which gives the Avi controller a way to automate the lifecycle of the service engine. It automatically discovers the port groups and networks and VMs in your VMware environment and automatically creates the service engines whenever required. The next thing to do is to install the AKO Avi Kubernetes operator in your Kubernetes cluster. Now, if this is a Tanzu environment, AKO automatically gets instantiated in it. But if you are using any upstream Kubernetes or OpenShift, you can easily deploy it using a Helm chart. and we'll see that in a demo. Once it's deployed, the AKO watches the API endpoint on Kubernetes side, and it also polls regularly to sync all the new services and load balancing objects that are getting created on Kubernetes. And it translates that and connects to the Avi controller over its REST API to configure corresponding virtual services on Avi. And Avi controller then manages the VIPs on the provisions the load balancing using the service engines. So after that, your application is up and running. I mean, your load balancing is ready to take in applications. So whenever your DevOps admin or your application developer creates an application and wants to expose that using an Ingress or a load balancer type service, AKO automatically gets notified. It translates that and creates corresponding virtual services on the controller. The controller runs its IPAM and fetches an IP address for the service. It also publishes the FQDN to DNS, and the VIPs are placed on the service engines. And your application is ready just like that. Now, whenever your client wants to access this application, whenever he browses to this application, the browser makes a DNS request, and Avi's DNS responds with the correct A record. That's how the client is able to route to the correct IP, the web for the application, which is sitting on one of the service engines, and the service engine is able to load balance it to the backend pool. So let's see this in action on actual demo. For the demo, what we have is a Tanzu Kubernetes cluster, TKG cluster, as you see out here, running on VMware. I also have the Avi controller already deployed, and we have configured the vCenter cloud out here. So we have given the vCenter host name, way to authenticate with it, and a bunch of configurations. And with that, your day zero configuration is done. So for the demo, we are using Avi's internal DNS to manage the FQDNs, and also Avi's internal IPAM. But like Palak said, we have integrations with all other third-party DNS and IPAM too. Avi also is a multi-tenant environment, so you can create tenants for each and every cluster that syncs up to the controller, so that you have management isolation between the cluster users. So our cluster will be creating virtual services in this demo tenant right now. So let's go ahead and see it on the Kubernetes side. So on Kubernetes side, like I said, the day zero operation is to create the AKO pod. So it's really simple. It's just a helm install command. You run helm install AKO, give the version of that, and you bootstrap it with your controller credentials and IP address and credentials, so that it can connect to the controller. And with that, the AKO will start running. And as you see out here, since I'm running it in TKG cluster, my AKO is already installed, so I won't be installing it again. But just running that helm install command brings up AKO, and it connects to the controller. Yeah, and our setup is ready to take in applications. So let's deploy a new application out here. Yeah. So with that, what I did was I created an application, and I'm exposing it using a load balancer type service. And with that, if you see, Avi or AKO automatically synced the configuration and created a corresponding virtual service on Avi. This virtual service is already sitting on one of the service engines running on VMware on the vCenter side. It is managing a pool of 2 pods in the backend, and your application is up and running just like that. And your user can directly browse to the IP address or even the FQDN of the application, and your application reach to your application, basically. Generally, people don't expose their applications as a load balancer type service. They go for Ingress, and they have lots of other security parameters around it, like they secure their Ingress using SSL termination and all. So let's create that and expose the same application with a TLS-based Ingress.
So, Bhushan, there are a couple of questions while you are doing the demo.
Yeah.
One is that for the demo, you are showing AKO. Are you deploying layer 4 or layer 7?
Like we said, right, Avi does both layer 4 and layer 7. The job of AKO is just to translate whatever is being created on Kubernetes side. So AKO will sync both load balancer type service, which is layer 4, which we just created out here. And it also syncs the Ingress type service, which we are just going to create now, which is layer 7. So with that Ingress service created, AKO will sync that service spec, as well as it will sync the secret, Kubernetes secret, which specifies the the certificate for that, and it will automatically create a virtual service as you see out here. And since the service engines are already deployed, the application does not take any time to come up. Like there is your application is immediately up and running. If you take a look at this, this is now listening on both port 443 and 80 running SSL. And if you go to the actual virtual service, it has the certificate already synced from the Kubernetes side, and it uses it as basically it syncs the secret on Kubernetes side as a certificate out here. So there is zero touch operation on Avi side. Everything is driven through the Kubernetes itself. Now, your Kubernetes spec is very limited, while Avi's configuration has a lot of features in it. If you edit one of the virtual services, you'll see we have various application and protocol policies that you can select. You have security ACLs, HTTP request and response policies, data scripts, something for analytics. Even on the pool side, you can select multiple health monitors, multiple load balancing algorithms, etc. To configure all of this, Kubernetes Ingress spec does not give a direct way to do it. So in order to configure that, what we have is we support custom resource definition on Kubernetes, using which we can configure all of these. For example, right now we have this service, but we want to make it more secure. So let's go ahead and do that. So with that, we created.
Yeah, no, another question was on the Ingress YAML definition. Can you share the Ingress YAML definition?
Sure. So yeah, the Ingress YAML was really simple. It's just a host rule with a path, and it is terminating SSL on this secret called TKG cert, which got synced into the Avi controller, and it's using that. But yeah, to customize this even more, we are applying this CRD. Let's take a look at that too. Okay, so what we have is called a host rule CRD, using which we can, for that FQDN, for the ingress of that FQDN, you can specify a new certificate, which is already created on the Avi controller itself. So you can divide your security and application tasks among your teams. So your security admin can log into Avi controller into the admin tenant and create required certificates. For example, if you see out here, you can go ahead and your application admin can create a certificate out here, and your application admin can go in and just reference that certificate. Similarly, your security admin can create a WAF policy, which can be referred to by the application admin. So you can divide the tasks of securing and providing your application, creating your application across the teams, or the same person can also do it. This is completely self-service portal on Avi. So with that, if you go back to the applications, now that we have applied this new rule to the, this new CRD's configuration to this application, you see that we have a small shield icon out here, which shows that it has the web application firewall enabled. So let's go through what all we configured. So we could configure a specific application profile for our for this application. we configured a specific WAF profile. We configured a specific error page. For example, if for some reason we want to return a 404 or 500, we can also specify the error page for that. We customized the SSL profile, added a custom certificate to this. On the policy side, also we added a new policy specific to our application where we can block embargo countries. We are rate limiting DDoS attackers and crawler bots so that we are making sure that our application is good with performance also. We can also apply some certain data scripts. So most of the things for request and response policies can be directly done using the HTTP request and response policies that we have out here. But just in case you have some application which requires certain things that is not directly available, you can also do that using data scripts. Basically script it out and let Avi run that script on your traffic. But yeah, 99% of your tasks will always be satisfied by this request and response policies out here. Similarly, on the pool side, we have something called HTTP rule CRD, using which we can set the LB algorithm. We can set what health monitors we want to apply. We can also re-encrypt on the backend side. I have just commented it out, so we are not applying that for now. But if your backend pods are listening on SSL, we can also re-encrypt and send it to the backend pods. So we can just take a look at that configuration here. So we applied multiple health monitors. We selected what type of load balancing we want to do. We have various load balancing algorithms out here that you can use. And yeah, with that, your application is up and running, and because of our DNS, this also gets published to the DNS, so you can directly browse to this, and as you see, it automatically got redirected from port 80 to port 443, but since we are using self-signed certificate, it's not it's showing not secure right now. And yeah, just like that, your application is up and running. So yeah, this application we just deployed, there's not much traffic on it. So in order to see the analytics, let's move on to another setup we have.
So Bhushan, for a multi-cluster, how many controllers are required?
Multiple Kubernetes clusters can home into the same Avi controller at the same time. Like each of these clusters will require their own AKO running, but all the AKO can point to the same Avi controller and on the same cloud. Yep. So yeah, so just for the analytics, let's take a look at another demo setup we have, which has application running for a long time and has a lot of traffic on it, so that we can see analytics. So just a look at your application out here, just like we had on the Kubernetes side, where we just deployed this application. Even here, we have a virtual service which is placed active on 2 service engines. And it has multiple pools on the backend side, which are over which it is doing a content switch, and each pool has multiple pool members or servers in the backend side. And as you see, just a bird's eye view can give you what's going wrong in an application if something is wrong. For example, your pod is down on the backend side, and you can see that health monitor is marking it down. So your pool health is down, which also affects your total virtual service health. So everything is tied together, and each and every object has its own health score, which is dependent upon different things like performance, resource penalty, because one of the resources down. There is anomaly penalty, which shows you if your application is facing some DDoS attacks, security penalty showing how good your ciphers are, how good your certificate is, and etc. And for each and every ingress, you can get this level of analytics and metrics, where you can see the end-to-end time, throughput, open connections per second, etc., across various time windows. And you can run it as granular as you want, as you see out here, or you can even average it out over time, depending upon how much data you want to collect and to process this. So, and this helps you to get to the root cause of your anything going wrong with your application. For example, between 7 and 8 a.m. In this graph, you see that the end-to-end time shot up. usually it will be attributed to some network latency, and the network team will get blamed, and then they will have to run network tests and TCP dumps to figure out where the bottleneck is. But just a look at this graph shows you that your green and blue part, which is the client RTT and server RTT, remains almost constant. What's changed was the app response time. So maybe there's something wrong with your application. Maybe there's something wrong on your servers because of which it is slow. Your network is perfectly fine. So getting to the the root cause becomes really simple, reducing your mean time to innocence. And there is no more finger pointing between teams. On the log side, yeah.
Yeah, so I think there's a question on what would be the use case for multi AKO, where we had the high level AKO architecture.
Yeah.
What is the need for I think multi-cluster AKO?
Yes, so maybe let me show that on here. Like I said, right, if you have multiple clusters running, you can have AKO running on each of them, but all of them can home back to the same Avi controller. You don't need multiple Avi controllers, and even the service engines can be shared across all of these. So whips from individual ones will be isolated on this, but the same service engine can service all of these. The main reason why people would do this is for redundancy, like HA or DR purposes. So say you have a production grade application, you want to deploy it across multiple clusters or maybe even across multiple AZs and data centers. That way you have the same application running on this cluster and the other cluster, and both of them can be serviced by the service engines. And in that case, you also need something called AMQO, which will tie these two ingresses together into a global service. Unfortunately, in today's demo, we are not going to talk about AMQO, but you can refer to our other Kubernetes demos and webinars where we have talked about this, and we'll do it in the future too.
And how do you connect the federated clusters across clouds?
Yeah, even across clouds, right? The architecture remains the same. It's just that for every infrastructure, say you have one cluster running on-prem on vCenter, the other cluster is running in AWS. The only thing that changes is the cloud configuration on Avi. That's the day zero configuration I was talking about. So if you go back to our demo, the first configuration that I showed you right now is that we configured a vCenter cloud. Similarly, we'll have another AWS cloud that we need to configure, and we have integrations with multiple cloud platforms. So each infrastructure will become a different cloud out here, and AKOs will connect back to the Avi controller on that cloud, and still can be managed from the same controller from a single pane out here.
Okay, thank you.
I think we are almost up on the time. I have some more. So can I go a bit more? Or?
I think, yeah, I'm trying to answer the question. So I would rather answer it here. So the
Sure.
question is that what is AMQ doing there? So Ranga, AMQ is multi-cluster, Avi multi-cluster Kubernetes operator that facilitates multi-cluster application deployment. So you can run that as a pod in the Tanzu cluster, and it helps you, extend application ingresses across multiple clusters for real-world deployments. Okay, are there any certifications for Avi? So we are working on the certifications for Avi, and we will definitely, we are in the process of, developing them and finalizing them. So we'll definitely, you will hear about the Avi certification soon. The other question is I think we are at the last second. Do I need both AKO and AMKO? Bhushan, do you want to wrap this question up?
No, so only AKO is required if you are using, if you want only local load balancing. Like I said, AMKO is only required if you have applications across multiple clusters and you want to bring them together, stitch them together.
Great. I think very interactive, great presentation. Thanks, Palak and Bhushan. It was a great session. I hope it was helpful. Thank you so much.
Thank you, everyone.
Thanks,
Bye.
everyone.